Okay, so welcome to our first video lesson. The topic of this lesson is going to be representing equivalent ratios. So I'm going to talk to you about how we can represent ratios. And then I'm also going to talk to you about how we can use ratios to kind of find some unknown quantities. So basically a ratio is a relationship between two quantities. So if we had a ratio that said 2 boys to 5 girls, okay, that would mean that for every 2 boys we had 5 girls. So the easiest way to represent this is with a poorly drawn picture. 2 boys and 5 girls, okay? And this just kind of shows that we have a lot more girls than boys. Well, how many more? Well, for every 2 boys, we have 5 girls. Okay, now let's think about a fraction here. We can write this very simply as a fraction. 2 boys to 5 girls, or 5 girls to 2 boys. You can write this using a semicolon, a colon. 2 boys to 5 girls, and 5 girls to 2 boys. Okay, so these are just some of the ways that we can represent a ratio. But now I want to think about some ratios that'll actually be equivalent to that first ratio. So maybe instead of just having 2 boys and 5 girls, we've actually got another set. We have 2 more boys and 5 more girls. Well, even though we have more students, we still have the same ratio. We have 4 boys to 10 girls, which is equal to 2 boys to 5 girls, okay? And I can get this by multiplying by really any number. So if you'll notice, I took my 2 and I multiplied it by 2, and I also took my 5 and I multiplied it by 2, okay, to get to my new number here. And we can do this for much larger amounts too. Let's say that we had 2 boys to 5 girls. Ooh, let me switch back to blue here. And we wanted to jump up to 50 girls, right? And 20 boys. Well, what that really is we're taking our original ratio and we're multiplying by 10. Right? So as long as we multiply both the boys and the girls by the same number, we get an equivalent ratio. Right? I'm going to take that and I'm going to kind of erase it. And we're going to now look at equal ratios and solving for a ratio. So let's say we have, again, we'll keep the same numbers. Let me get my pen feature back. Let's say we have 2 boys to 5 girls. Okay. But now let's think about, maybe instead of having 5 girls, we've got 30 girls. Okay? And our question, our question is going to be, well, how many boys does that have to be? So if we think about it, we have our original ratio of 2 to 5, right? And we know that there's some number of boys and 30 girls. Well, you can pretty quickly think about, how we turn that 5 into 30. Well, what did we have to multiply by? Of course, what we were multiplying by times 6. Well, if we did 5 times 6, we can also do 2 times 6. And 2 times 6 says that I'll have 12 boys. Okay, so we can use this idea. We call this a scale factor, right? Let me write that in there. Scale. Sorry about that switching going on. Scale factor. Okay. We can also use a couple of other ideas here. We can also set up a proportion and cross multiply. So we know we have 2 boys to 5 girls. And we know that that's some unknown, so we'll call it x, right, which you saw in middle school, divided by 30 girls. So when I say cross multiply, I know that you've seen this before. I'm going to take my 5 and I'm going to multiply it with x. Not a very straight line, but that'll work. So 5x, and I know that that's going to be equal, and I'll do this one in green here, to whatever this product is. And 2 times 30 gives me 60. Okay? So if I cross multiply, I get a pretty simple equation to solve, right? To solve this, the inverse of multiplying by 5 is dividing by 5. And I have to do the same to both sides. So I end up with x equals 12, right? Same solution. I still have 12 boys, just like I got the other way. Okay, so we can either use a scale factor, right, and figure out what we have to multiply by, okay, or we can set up a proportion. One thing to note is that it's important to be consistent. I'm writing all of my ratios here as boys on top and then girls, right? We always have to set it up the same way when we're solving these problems. Okay, now the last thing I want to talk to you about is a ratio table. So let me clear all this out. So a ratio table, and let's go back to blue here for a moment. Ratio table. Okay, it's just going to show me different combinations. So let's think about that 2 boys to 5 girls. And I'm going to set up a ratio table. And I just want to, I'm going to pick boys here. And then I'm going to figure out for every number of boys, I'm going to figure out how many girls that corresponds to. So, you know, our original ratio was 2 to 5. 2 to 5, okay? And one thing that may be helpful as we work through some of the harder problems in class is adding a column for total, okay? So 2 boys to 5 girls, well, that's 7 total kids, right? Well, an equivalent ratio would be 4 boys to 10 girls, okay? And the way that I got that, of course, was by multiplying by 2, giving me 14 total students. And let's say I had some number of girls here. Let's say it was 50. I want you to take a second to think about how many boys that would represent. There are 50 girls, how many boys I would need. Okay, so if we think about that, 5 times 10 gives me 50, so 2 times 10 gives me 20, giving me 70 total. Okay, so one problem that you're going to have to think about for homework is, well, what if I had, I don't know, 21 total? And I would have to figure out how many boys and girls that is. Well, if I use this total column carefully, 7 times 3 gives me 21. So 5 times 3 gives me 15. And 2 times 3 gives me 6. Okay, so there's that certain combo that gives me 21 total students. So that's the end of the lesson for today. You can use this video as you complete your homework and be prepared to discuss in class tomorrow.